All right. So as I was saying, guys, we're doing lesson 4. It is titled, How Far Is It from Typical? Okay. I found that lesson 4 is going to be a two-parter. So we're going to do the first half today, and we'll finish up the second half on Tuesday next week. Okay. Friday is too short of a time. So we are going to be doing lesson 4 in 2 days. Okay. So to get us started, I want us to take a look at our objective and our essential concepts. So as I mentioned earlier, um, we spent 2 days or 2 lessons, I should say, on looking at center or measures of center, right? We looked at the mean. So we learned about the mean as the center or as an idea of typical. And then we looked at the median, right? And we looked at the median as another measure of center, that when the mean is not a really good accurate representation of this of typical or center, we can use the median. Okay. So today, however, we're switching gears, and instead of talking about measures of center, we're going to be talking about measures of variability, measures of spread. So our objective for today is that you will understand that the mean of the absolute deviations, okay, the mean of the absolute deviations, that's one thing, okay, also known as MAD, is a way to assess the degree, the level of variation in the data from the mean. So the MAD is a way to see how much variation there is in our data from our center, the mean. Okay. It adjusts for differences in the number of points in our data set. So the number of points number of data points or observations that we have in our data set definitely affect our MAD value. Okay. The MAD measures the total distance between all the data values from the mean and divides it by the number of the observations in the data set. Okay, so the MAD measures the total distance between all the data values from the mean. Okay, so what does that mean? That means we look at the distance of each data value from the mean of that data. We see how far it is, right? How far is this data point from the mean? How far is this one from the mean? And then it takes their average and it finds the mean distance. Okay. And I know that sounds really confusing, but when you see it in action, you're going to be like, oh, that's not that confusing. So our essential concept, guys, the essential concept always gives you some very good things to notate in your notes. Okay, the essential concept is that the MAD, the mean of absolute deviations, measures the variability in a sample of data. Okay, this right here is important. The larger the value, the greater the variability. Excuse me. The larger the value of the MAD, the greater the variability. Okay, we'll see that in action. More precisely, the MAD is the typical distance of observations from the mean. A typical, in this case, talking about the average or the mean distance, right? So it is the typical distance of observations from the mean. Okay. There are other measures of spread as well, just like there were multiple measures of center, right? We also have other measures of spread as well. And that is the standard deviation, which is something we'll talk about later on, as well as the interquartile range, also known as IQR, which is something we'll talk about later on as well. Okay. So we have other measures of spread or variability to discuss later. First things first, though, let's take a quick look at, let's do a quick journal entry. And yes, you are going to be writing this in your journal. Okay, and I want you guys to complete So this is a little summary of lesson 3 from earlier in the week. It says you learned about 2 different measures of center during the previous 2 lessons. You learned about the mean and the median. Okay, so these sentences are already in your journal for you, right? So I want you guys to fill in the blanks with the appropriate words, okay? Mean is used with blank distributions. The median is used with blank distributions or when there are blanks, okay? So this is directly related to the last topic of discussion we had for lesson 4 after we did the second activity in lesson 4. But I'm going to go ahead and I'm going to give you guys a word bank to work from if you would like. Some words that we used during our last lesson. Hey, not all of these are going to fit in here, so you pick the ones that you can. So we talked about center. We talked about different types of distributions, so symmetric, skewed. Okay, we talked about, we had this word here, outlier, right? So some words to consider for our blanks here. I'm going to give you guys a minute to complete your statements here, okay? I'm going to give you guys a minute to complete your statements here and in your journal, and then we'll ask a few people to contribute. Okay, so today I'm looking for volunteers first and foremost, and then we will talk about calling on people, okay? And I am going to keep track of my volunteers and who is participating here. So if you would like to contribute your statements here, I need 2 people, please. 2 people to volunteer to complete our statements here. Okay, Samai, that is actually incorrect, hon. Oh, let me clear my lowered my hands. I lowered everyone's hands here. If you would like to volunteer for the statements, to complete the statements, please raise your hand. Okay, David. Hey, David, go ahead and complete the statement about the mean.
Okay, so for mean, I put is used with symmetric distributions.
Very good. The mean is used with symmetric distributions. Absolutely. So over here we have symmetric. Okay, and then Janelle, my dear, can you please go ahead and give me the median? Actually, I don't know who was first. Did Janelle raise her hand first or Katie? I did not see that. Okay, so Janelle, go ahead. Complete the statement with the median.
Median is used with center distribution or when they are skewed.
Um, mm, not one there. The word skewed should go here, but not in that place. So
They
if
are
the
like
mean, if the mean is, so centered distributions
mhm.
and symmetric distributions are synonyms.
Oh, okay.
Yeah.
Okay, so is it median is used with outlier distributions or when they're skewed, or did I like mix them up?
Yeah, you didn't make anything up. You kind of mixed them up. So an
Oh,
outlier is a data point, right? An
mhm.
outlier is a data point, so it can't be a distribution. You want to do one last try and then, or do you want to pass it on to someone else?
Katie can go.
All right, Katie, you want to take a stab at it, Katie?
Yeah, sure.
Go ahead.
I was gonna say median is used with skew distributions or when there are outliers.
Yes, very good. So Janelle, you kind of had the words, but you mixed them up, right? So skewed and symmetric. Well done, Katie. Thank you, hon. Skewed and symmetric are types of distributions. They are essentially the different ways that distributions can be, the different visual representations, right? So the median is used with skewed distributions or when there are outliers. Okay, so if you guys remember from lesson 3, right, we had our right skewed and our left skewed distributions that we looked at, right? In that case, our mean and our median were not the same, right? With the symmetric distribution, our mean was approximately the same as our median, okay? But with the skewed distributions, one was greater than the other, and so they weren't exactly the same. And then of course we had our outlier, right? We remember the example of the 27 zeros. We had our example of the 27 zeros and then the 1 million at the end, where the 1 million here would be considered our outlier. Okay, something that's very different than the rest of my data, that doesn't follow the pattern of that data. Okay. All right, thank you to you guys. Thank you to David, Janelle, and Katie, okay, for guiding us through that discussion there. Okay. Okay, so in addition to understanding the center of our data, we also need to understand the spread of our data, the variability in our data. We've been talking about variability and how important that is with our statistical questions. But we also want to understand how to notice and see variability in our visual representations of our data, but not just the visual representations, right? We also want to be able to understand, just like when you're told the mean, right, or the median, you're being told what the center or the typical value is in your data. We also want to understand the spread of our data, because the mean or the median doesn't necessarily give us all the information about our data, right? If someone just told you the mean, it wouldn't really give you a lot of information other than what's the typical value in your data, right? If I said the mean height of teenage girls is 5'6", that tells you the average height, but it doesn't tell you the variability in your data. It doesn't tell you how much the data is spread, right? It doesn't tell you, okay, the average is 5'6", but what's the shortest? What's the shortest data? How high does the data go? Who's the tallest person? Not who, but what's the tallest height? What's the shortest height, right? What are the heights in between? So it doesn't give you that information just with the mean. So understanding the spread of our data, understanding the variability in our data gives us a better picture of our data, especially when we don't have a physical visual picture to look at. So let's take a look at what we're looking at today. So looking forward, in today's lesson, you will learn about measures of variability, okay, AKA also known as measures of spread, okay? These values show us, so the measures of spread or variability, show us how much quantitative data. Okay, quantitative is just another word for numerical. So we can only use this measure of spread or variability, right, and mean and median. It really only applies to numerical data that's numbers, right, not categories. So these values show us how much quantitative data varies from the center of a distribution. So how much variation our data has from the center of our distribution, the mean or the median, okay? Similar to the measures of center, you will use two different measures of spread, okay? You'll use the mean of absolute deviations, which is what we're talking about today, okay? It is shorthand MAD, the mean of absolute deviations, and we will understand every single part of this. We will understand the mean, like what does the mean have to do with this? What does absolute have to do with this? What is deviations, okay? Think about that word deviations. And then we're gonna also look at something called the interquartile range, the IQR, okay? The interquartile range. So, but right now we're really focusing on the mean of absolute deviations. That's our focus today. Okay, I'll give you guys another minute to make sure you have all of this down. And then always remember, guys, if you don't catch something, you're always, you can always have your PowerPoint open while we are doing our notes here. So we have our next journal entry. Our next journal entry is me asking you to write what you think the word deviation means. What does the word deviation mean? Okay, and think about how could it relate to variability? How could it relate to the spread or variability, right? And I want you guys to think about at least 3 common synonyms like fluctuation or modification, or even more simpler words. So I fully expect that some of you guys will might have never heard of the word deviation. So I encourage you to possibly, do a little search and see what you can come up with deviation. See if you can understand what deviation means, and then we'll connect it to our lesson for today, and we'll connect it to the variability. So, but I want you guys to put down your thoughts here, okay? So I'm going to give you guys 2.5 minutes, 2.5 minutes to complete this journal entry, okay? 2.5 minutes to complete this journal entry, and then we'll discuss it. And once again, I will take volunteers, or I will be choosing my victims to participate, okay? 2.5 minutes. Go ahead and finish up whatever statement that you're writing in your journal there. Bring it on back. And I do want to see, let's have some volunteers. I would like to hear from a few people, okay, what they think the word deviation means. How could it relate to variability? Maybe some common synonyms. Let's see if we can get some people to participate here. Okay. Not necessarily, so one of your classmates did say opposite. It's not necessarily opposite. It's not necessarily opposite. Okay, the difference between two variables. Okay. Measures of difference. Interesting. Measure of difference. So someone says, is it like a sense of direction? It can have a lot to do with direction. Yes. It can have a lot to do with direction. Anyone have like maybe like a nice definition that they might have put down of what that word might mean? Deviation. Okay. Switches from a value. Interesting. Okay. Difference in distance. Yes, possibly, yes. In this case, that's exactly, in this case, in the case of the mean of absolute deviations, that's exactly what it is. It's the difference in distance of variables from the mean, okay, or of data values, I should say, of observations from the mean, not variables. But did anyone think about like the word deviation in like the real world outside of the world of math? Okay, what does it mean to deviate? What does it mean to deviate? Depart, yes. Departing, leaving. Okay, how would you understand it if I said Little Red Riding Hood deviated from her path in the woods? Okay, changing from an established course. Yes, you guys really need to start contributing publicly. Okay, start contributing publicly so that you guys can have a discussion with each other as well. No, you're not the only one, Maya. Don't worry. That you think you're the only one because all the other people also did it privately. Yes, Dallas, shifting, absolutely shifted, right? Deviating is changing course or change essentially, right? To deviate is to change direction or change from a given path or a selected path, as Maya said, changing from an established course. Okay. We deviate from things all the time, all the time. A very simple thing, right? You sit down to do homework and then you deviate to your phone, and then you're essentially stuck in Instagram world for 3 hours or TikTok world for 5 hours. So we deviate all the time. It's something that we do all the time, right? But in the sense of our class today, right, for the mean of absolute deviations, we are specifically talking about this definition of the difference in distance, okay? The difference in distance. And you guys are gonna see exactly what we're talking about there mathematically in a quick second. Okay, so what we're going to do now is we are going to actually go to our 2.4a variability in a basketball worksheet. We're going to go to our variability in basketball worksheet. And what we're going to do is we're going to kind of do things on and off. I'm going to give you guys some time to answer questions. We're going to do some questions together. And then I'm going to have you guys do a part of it again yourselves. Okay, so it's going to be kind of a back and forth kind of deal. So I'm going to switch my screen here, switch my screen to my Google, and let's go to our 2.4a. Here we go. That's the one I want. Excuse me. Okay, so 2.4a. Let's take a look at this guy. We are given some basketball stats, but in the form of a dot plot. Okay. So the directions are complete the following questions and tables in blue font. Okay, so let's take a look at the two visuals that we've been given here. Okay, first of all, this is titled Terry's Baskets and this is titled Chris's Baskets. Okay, and then at the bottom here, it says baskets scored per game. So baskets scored per game. So what does that mean? That means each one of these dots on this dot plot represent the baskets scored each game, right? Or during a game. So that means that this dot right here, this basketball represents that in one game, Terry scored 9 baskets. In this one game, Terry scored 9 baskets. Another game, he scored 9 baskets. Another game, 9 baskets. Another game, 9 baskets. And then there were 4 separate games during which Terry scored 10 baskets each game, right? So 10 baskets, 10 baskets, 10 baskets, 10 baskets. Okay. And then we're given Chris's baskets. So here's Chris. And again, baskets scored per game. So in this case, Chris, there was one game that Chris only scored 2 baskets, another game that Chris scored 5 baskets, and then so on. And over here, there was actually a game that Chris scored 15 baskets. Okay. So the questions I want you guys to think about and answer right now. It says the coach notices that the mean and the median for both players is the same. Can you find the mean and the median for both players? So number 1 is asking you to find the mean and the median for both players. Number 2, do you think that Chris and Terry performed equally well during the first 8 games of the season? And number 3, what is different about Chris's and Terry's performance on the basketball court? Okay, so you're answering numbers 1 through 3 for in the next 5 minutes. I'm going to give you guys 5 minutes to answer questions numbers 1 through 3. And then number 4, calculate the mean absolute deviation for both players. Number 4, we're going to be doing together. Okay, part of it we're going to do together. So right now we have 5 minutes for you to answer the numbers 1 through 3, starting now. What's our mean and median for both players? Mean and median for both players. Let's see. Valerie, go for it. All right, Val, thank you. 9.5. Okay. Janelle, confirm or did you get something else?
No, I got 90 for both.
So you got 9.5 as well, right on. Okay, so we got 9.5 for both players, yes? Okay, we should have gotten, so our mean and our median here, let's see. Wanting to write, so mean and median are both 9.5 here for both players, okay? Before I move on, I actually want to just do a quick review on how we find our mean and our median. For those of us that might have been stuck with that. So quickly, right, to find our mean, we add all our numbers together and then we divide by the number of data points that we have. So we're going to be dividing by 8 here. Okay, we're going to be dividing by 8. So over here, I have 4 dots above 9. So I can do 9 plus 9 plus 9 plus 9, or I can just do 4 times 9 because I have 4 dots above 9. And then I have 4 dots above 10. So I can do 4 times 10, or I can do 10 plus 10 plus 10 plus 10, right? Either way, this does come out to a 9.5, okay? For this one, it's a little bit more varied because Chris has a little bit more of differences in his scores, right? So over here, we'll have like a 2 plus a 5 plus 2 8s plus 11 plus 13 plus 14 plus 15, losing space, divided by 8. Either way, that does come out to a 9.5. Okay. Thank you, Sarai. Okay. So we get that 9.5, right? Whenever we add, I think Sarai said that adds up to 76 over 8, which is 9.5. So the mean is just the average, right? Our median, however, okay, median, just to show that we can get the same thing, we have 8 games, right? We had 8 games played, or we have 8 data points. I want to find the halfway mark between that. So that comes out to 4. So our median, okay, the halfway mark is 4. So since it's a whole number, that means I'm going to be looking at the 4th and the 5th terms in my data. The 4th and the 5th values in my data. So what does that mean here? So over here for Terry, I'm going to come here. This is 1, 2, 3, and 4. And then 5, 6, 7, and 8, right? So 4th and 5th terms, that's a 9 from here to that basketball. And then that's a 10. The 5th term is a 10. So 9 and 10, they have to average them, and I get 9.5. I get 19 over 2, which is 9.5. Okay. Similarly for Chris, again, we have 8 data points. 1, 2, 3, 4, 5, 6, 7, 8. Right. So again, halfway mark is 4. It's a whole number. That means I'm going to look at the 4th and the 5th data point. So I have 1, 2, 3, 4. So the 4th, 5, 6, 7, 8. So this is going to be the 4th and the 5th. The 4th data point is an 8, has a value of 8. The 5th data point has a value of 11. So 8 plus 11 divided by 2, that's going to be, again, 19 over 2, which is 9.5. Okay. So either way, we got our means and our medians. Again, we averaged these two because we had a whole number as our middle point, which meant that we have 4 on one side and 4 on the other side, so on. Okay, if we had a decimal, if there's like a 4.5, then we just look at the 5th number. Okay, so quick recap of lesson 3 with our medians. Okay, sorry about that, I kind of hijacked. And as Janelle and Val told us, our mean and our medians are 9.5. Okay, now what do you guys think? I want to hear from you. I would appreciate it if someone would unmute, but if not, then make sure that you are sharing publicly in the chat. Okay, and remember that I am keeping track of participation. So what do you guys think? Do you think that Chris and Terry performed equally well during the first 8 games of the season? Go ahead, Dallas.
So what I wrote was, I believe that they kind of did do the same, like did do good, because like if you look at the number of baskets, Terry's is kind of consistent with a 9 and a 10, but Chris's baskets vary. And I mean, it kind of levels out because you know how like Chrissy has 2 points, but then he also has 11, 13, 14, 15. So like if you're looking at like overall, they have the same, but as far as like how many baskets they get a game, then there would be a difference.
Okay, thank you, Dallas. Well said. Janelle, you want to add?
I said that they didn't perform equally because the question asked during the first 8 games, and Terry didn't score any the first 8, but Chris did, and he scored 4 baskets.
Wait, hold on. Let me clarify, sweetie. This is not game 9.
Oh, it's like
This is how many baskets they scored per game. So this means that he scored 9 baskets in one game, 9 baskets, 9 baskets in another game, and so on.
Oh, okay, then yeah, I agree with Dallas.
Okay, thank you. Yeah, you know what? You're not the only one that's had that confusion. I had like my other classes too. I had a few kids have that confusion. It's the number of baskets they've scored, not which game, right? Sarai, you want to add on?
I agree with Dallas. I said the same thing as her, how well, they pretty much got the same score in total at the end, but Terry was more consistent, and like Chris, he like he got like different scores each game.
Okay, all right. Thank you, Sarai. So you guys kind of answered 2 questions in one. Look at you being all sneaky. You guys answered 2 questions in one, which is cool. I like it. And you answered number 2, but you also answered number 3 of what is different about Chris's and Terry's performance on the basketball court. Okay, and you use the word consistent, right, for Terry. You use the word consistent for Terry, and you kind of said that Chris was a little bit all over the place, right? So this actually has a lot to do with variability and spread of data. Okay, so visually, let me ask you, visually, who has more spread in the data? Terry or Chris? Okay, and
Chris.
you guys, Chris has a little bit more spread in the data. What do you guys think? Let me know in the chat. Let me know. Thank you, Maddie. Thank you, Janelle. Thank you, Vicky. Thank you, Val. Thank you, David. Thank you, William. Guys, I want to see participation. If you're not participating, guess what I'm thinking? I'm thinking you're not paying attention. Okay, thank you, Maya. Thank you, Ishmael. Thank you, Natalie. Thank you, Dario. Thank you, Sarai and Alexander. All right, so most of us think that Chris has more spread in his data, right? So I want you guys to keep that in mind. So Terry, we said, is more consistent, and Chris, we're saying, has a little bit more spread in his data. Okay, so that's going to, and I want you guys to keep that in mind when we find the mean absolute deviation. Okay, when we find the mean absolute deviation. So what we're going to do is we're going to go ahead and we're going to calculate the mean absolute deviation for both players. I'm going to do Terry's with you to show you how it's done. Okay, and then you're going to do Chris's on your own. Okay, you're going to do Chris's on your own, and then you're going to answer those two questions. So let's take a look at Terry's first. How do we find the mean absolute deviation? Okay, so do you remember that we said that deviation, I think that's an E, deviation is the distance from the center, right? We said it's the distance from the center. So if we take a look at that, this right here, this is our deviation. This is how we find the deviation. We take our mean, which in this case, we have our mean for Terry's scores, Terry's baskets is 9.5. And then we're going to subtract it from each score that Terry got. We're going to subtract it from each score. So Terry scored 9, 9, 9, 9, 10, 10, 10, 10. So to find the distance or the difference, the deviation here, I'm going to do 9.5 minus each one of my scores here. So the first four, my scores are the same. So it's going to be 9.5 minus 9, 9.5 minus 9, 9.5 minus 9. And then my score changes to 10. So it's going to be 9.5, my mean, that doesn't change, minus 10. 9.5 minus 10. 9.5 minus 10. 9.5, again, one more 10. Okay. So I'm literally finding the difference between my mean and each one of my observations, each one of my scores. Okay. Amani, I got you, hon. Don't worry. Thank you for letting me know. All right. So then to actually get the deviation, that difference between them, I'm going to do the subtraction here. 9.5 minus 9 is 0.5. Okay. So each one of these, 9.5 minus 9 is 0.5. 9.5 minus 9 is 0.5. 9.5 minus 9 is 0.5. 9.5 minus 10 is negative 0.5. Negative 0.5. Negative 0.5. Negative 0.5. So the deviations of each score, right? And Terry's looks so uniform because we have so much repetition in his scores. Yeah. So I see a lot of similar deviations here. Okay. Now, so this is the deviation. We just found the difference between our mean and each observation, each score. Okay. And then the absolute deviation. What does that mean? I have the deviation. What the heck's the absolute deviation? Well, this just means take the absolute value of the deviation. That's all that means. It means take the absolute value of the deviation. Okay. So remember, distance is always positive, right? We don't say I walked negative 2 miles. I say I walked 2 miles south. So distance is always positive. So we're going to take the absolute value of our deviation here. And absolute value just means whatever is negative turns positive, whatever is positive stays positive, right? So this is 0.5, 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 right? Turns negative into positive, 0.5, 0.5, and 0.5. Okay, so here are the absolute deviations. Okay, the distance of each score from the mean, but the positive distance. Now, we found each individual absolute deviation, okay? But the MAD stands for mean of the absolute deviations. The mean, AKA the average, okay? So how do we find the average of something? We add them all up together and then we divide by the number that we have, right? So what we're going to do is we're going to take all of our absolute deviations here and we're going to add them all together. So 0.5 plus 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 0.5, which gives us a nice 4. Okay. And then what do I do with that 4? I'm going to show you in a second. I want to make sure you guys have all this down. So I'll give you guys another 30 seconds to make sure you have it down. Okay, another 30 seconds to make sure you guys have this down. And then we got our added, right? We added all of our stuff together. So we're going to do our 4 here divided by the number of data points that we have. 1, 2, 3, 4, 5, 6, 7, 8. So 4 divided by 8. That's going to give me the mean of my absolute deviations here. It's going to give me the mean of my absolute deviations. So bringing this down here, right? So finding the mean of our absolute deviations is just like finding the mean of the scores, right? It is just like finding the mean of the scores. All we do is we add up the total, right? In this case, we're adding up the absolute deviations, which we added up to 4. And then we're dividing by the number of observations that we had. And that's going to give me a 0.5. Okay, so Terry's MAD. Terry's MAD, mean of absolute deviations, is a 0.5. Okay. So I want you to look at this. Is this a big deviation? Is this a big number or a small number?
Small.
Yeah. Okay, so this is very small, right? It's close to 0. So what does this mean? What does a mean absolute deviation like represent? Well, it's kind of saying, if I have my number line, right? If I have my number line, here's my mean. This is my mean value, 9.5. This is saying that the average distance of the data points for Terry, or the scores for Terry, the average distance are only 0.5 to the right and 0.5 to the left. So most of the data points, it's saying, kind of fall in this distance from our mean. And our mean is right there in the middle, okay? So that's not much of a distance, right? It's pretty much saying most of your data points for Terry are right around the mean. They're centered around the mean, AKA they're consistent around the mean, right? So we're going to compare this MAD to Chris's MAD now. So what you guys are going to do for the next, I'm going to say 6 minutes, okay? What you're going to do for the next 6 minutes is you are going to calculate the MAD, the mean absolute deviation, for Chris. Okay, so remember that for Chris, our mean was the same, right? Chris and Terry had the same mean, 9.5. So this is 9.5 minus each score. Okay, so you guys are going to spend the next 6 minutes calculating Chris's MAD, mean absolute deviation, following our table and the guides here. And then you're going to answer the 2 questions at the end. You're going to answer, what is Terry's mean absolute deviation? Is it closer to 0 than Chris's? What does this mean? I kind of already answered that for you. You're just going to put it into your own words. And then what is Chris's mean absolute deviation? Is it higher than Terry's? What does this mean? Okay, so I want y'all to go ahead and spend the next 6 minutes working on Chris's mean absolute deviation and answering these questions here. Okay, ready? Go. Okay, do me a favor here. I put down the work for you guys to check. If you have the correct work, and once you add your absolute deviations together, if you have this correct, please raise your hand for me. Okay, there's no shame in not having correct. Just find your mistakes here. Okay, raise your hand if you were able to get the sum of the absolute deviations as 30. All right. Okay, so anyone of you that don't have your hands raised, anyone have a question or need a clarification on any part of this? Okay, now would be a great time to ask your questions. Now would be a great time. Okay, let's see. Understand where. Okay, thank you, Ishmael. Thank you for letting me know you got your mistake there. Okay, any questions, Chris, Gabby, George, Samai, Alexander, Trinity, Tyrese, Val, William, any questions? Okay, okay. So we got some simple maths issues happening here. That's totally fine. Okay, I got you guys. Yeah, okay, all right. All right, so now since you have your total, right, your sum, since you have your sum here, now you're gonna make sure you take it down to your, so over here, guys, right, when we add, so this here is just the average mean score here is just to help you connect how we're finding the mean of the absolute deviations, right? So to find the mean of your data, you're going to add all of your data points together, which according to Sarai earlier, or Sarai, I'm sorry, earlier, was 76. And then we put that over 8 and we got that 9.5 here, right? So then using that same concept, we're bringing it over here to the mean absolute deviation. And with the mean absolute deviation, we have the total of our absolute deviations, which we got as 30. And we're going to be dividing that by 8. Okay. And that should have given us a 3.75. That should have given us a 3.75 there. So using that information, okay, using that information there, we can now answer these two questions. So who would like to contribute here? Who would like to contribute? What is Terry's mean absolute deviation? What was Terry's mean absolute deviation? Go ahead, Dario.
Terry's mean absolute deviation is 0.5, and this shows the variability is a lot less than Chris's, since it's a lot closer to 0.
Ah, shows that the variability, hold on, I have too many windows open. Variability is, what did you say?
A lot less than Chris's.
A lot less than Chris's, since it is close, right?
To 0.
It's closer to 0. Very good. All right. Thank you, Dario. Knock that one out of the park. Okay. What about for number 6? So what is Chris's mean absolute deviation? Is it higher than Terry's? What does this mean? Here, I'll switch colors at this point. Any takers? Any takers?
I'll do it.
Go ahead, David.
Okay, so for number 6, which is Chris's, his mean absolute deviation is 3.75, which is higher than Terry's, and this means that there's more variability.
Mm-hmm. Very good. So it means he has more variability. Absolutely. Okay. Thank you so much, David. So really quickly, guys, for Terry, right, I drew the thing where I had the 9.5 and then I had the 0.5 here, right? And then the 0.5 here. For Chris, similarly, what that means is that the mean absolute deviation, right? Our mean is still at 9.5. The only difference is since his mean absolute deviation is 3.75, that means his data values have an average distance from the mean that is 3.75. So this distance is 3.75. This distance is 3.75. Okay. So what this is saying, that this doesn't mean that every point falls between these two lines. It means that this is the average distance. So you have some points that are really close. You have some points that are more far out, right? But this is the average distance. And we're seeing that. We see that very clearly because Dallas earlier on said that Chris is showing way more variability in his data, okay? Chris is showing way more variability. This is not going, seriously, here. Okay, in his data, we can see that right here, right? If our mean for Chris is 9.5, here's 9.5, right? Here's our average. Here's our mean and our median. Okay, so we can see that there's a lot more variability in our data for Chris versus if I take a look at Terry's, right? Same spot here, Terry's 9.5 right there. But notice Terry's is very, very close to our mean. Our data is literally only between these two lines right here. And here is our mean right there. Okay, so you're like, what's the point of MAD though? I can see that. I can visually see that there's more variability with Chris, right? What's the point? The point is that a lot of times you're not given a visual representation. You're just given a mean. And if we were just told that our means are 9.5, would you have guessed that there could be these two different sets of data that would get the same mean of 9.5? Just knowing that the mean of the data set is 9.5, would that give you this visual representation? No, right? But if they also told you, hey, the MAD is 0.5, then this is telling you we have a mean of 9.5 with not much variability. Versus if they told you the MAD is 3.75, then it would tell you, oh, this is my mean and it has some variability. There's some spread in my data. Over here, not so much spread. Over here, more spread, okay? So this brings us to our PowerPoint once again. And I want us to get this down here, okay? Especially this part right here. When our data are quantified with numbers, we can calculate how far each value is from the center, okay? We can calculate how far each is from the center. And then I want you guys to, we're gonna close things out with a journal entry. I'm gonna have you guys summarize our thoughts here and a journal entry. Okay, so I'm just leaving this up here for a few more seconds while you guys get that bit. And then I want us to close out today. We're not done today. Remember I said this is gonna be a 2-day thing for us. So we're gonna close out today with this nice summary of a journal entry, asking you what is MAD? Okay, what does the mean stand for? Okay, and I give you that. The mean is our average, right? When we find the mean part of mean absolute deviation is the average. We're finding the average of the absolute deviations. What does the absolute have to do with it? What does absolute mean? What does deviation mean? Okay, as far as the MAD goes. How was this process for you? How was the process of finding the mean absolute deviation for you? And what does the mean absolute deviation actually mean to you? Okay, so we're ending the class with you guys completing this journal, and we will take your responses at the beginning of our next class on Tuesday. Okay, so yes, I want you guys to stay on and complete your journal, and I will dismiss you at 12:04.